All right, had a lot of requests for this one. I'm going to show you how to take the images off of your Dwarf 2 unit, bring them over into your PC, and process them using Siril. This will give you a lot better end result image because you're going to be in control on how the final image looks. The first thing I wanted to bring up about the video is this is directed towards the absolute beginner, somebody who has a Dwarf 2 and has never looked at Siril before. So I'm not getting into any of the advanced features of Siril. I have lots of videos that cover those more in depth if you want to go another step beyond this video. But for now, I wanted to keep it simple and understandable for those of you that have never pre-processed and stacked your own images before. So the first part of the video, I'm going to show you how to shoot your own set of darks. I'm not talking about the Astro dark function within the Dwarf 2. It's the same thing, but that function only takes 3 dark images. We need more than 3 in order to get a better result out of this. The darks will take care of not just the hot pixels, but also thermal noise that may be generated from the camera sensor during these long sessions. So I'll show you how to shoot your own set of darks. Then we're going to move into how to get the darks as well as the images you took that night off the Dwarf over into your computer. Then we'll jump right into pre-processing and stacking using a custom script from Siril. So let's talk about the giveaway that I announced a couple weeks ago. Right now, long story short, we need to hit 3,000 views in order for me to give that unit away to one of the viewers. And we haven't quite hit that 3,000 mark yet. Last I checked, we're about 800 views short. But I had a thought, so I reached out to Dwarf Lab to see what they thought about it. I've now done 3 videos around the Dwarf unit, 4 counting this one as soon as it's uploaded. And total with those 3 videos, we're a little bit over 4,000 views right now. But the main reason I emailed them and asked them if I could give this thing away a little bit earlier before we hit that 3,000 mark is because I want to do the giveaway on December 11th. December 11th is the 1-year anniversary of Deep Space Astro, this channel right here. December 11th was my very first video that I uploaded. It was a cheesy montage video of images that I took the year prior. If you haven't seen it, please don't go watch it because it was really bad. But I thought that would be a really cool day to pick to be able to give this thing away. And to my surprise, they agreed. They thought it was a great idea. So they have given me the go-ahead to give away the Dwarf 2 to one of you guys. If you haven't seen the video, I'll leave a link up here. Go check it out. There's instructions on how to enter the contest there. If you're subscribed, you might want to consider turning on the bell notifications so you'll get a notification when I put another video out because I am planning on doing this live. And I laugh because I've never done a live stream before. My main concern with it is my internet can be spotty sometimes. So hopefully it's stable that day. December 11th is a Monday. Not sure what time yet, but again, if you set your bell notification, you'll get that notification and you can tell YouTube to remind you for the upcoming event. More news, during my conversation with Dwarf Lab, they surprisingly told me that they have set up another giveaway on their side that they're going to be handling where it allows me to give away a second Dwarf 2 unit. I'll leave the link in the description of this video where you can go and sign up for that giveaway. So now you guys have 2 chances to win one of these things. I was really shocked when they told me that they had done that, so that's awesome. So all right, that was a really long intro, but I wanted to cover a bunch of stuff for you guys. Let's get into processing the Dwarf 2 with Siril. My name is Rich, and you're watching Deep Space Astro. Okay, before we start shooting our darks, there's a couple settings that you want to turn off here, and that's around this green light and the power indicator lights down the bottom. Just in case that light makes its way into the camera lens, we don't want that on our darks. So if you want to hit your settings button, go to camera settings, and the first one we're going to turn off here is under power management, and that says power indicator light. You turn that off and the 4 lights on the bottom will turn off. The second one is indicator light. This is a bug in the app. I've let Dwarf Lab know about it, so hopefully it'll be fixed in the next release. You can see the green ring is on now, but the indicator light switch is showing that it's off. So you just need to tap it to the on position and then to the off position, and now that light goes off. So now we're ready to get this into the bag to start shooting our darks. We're going to flip the lens down. We're going to turn it upside down and put it into the bag and zip the bag up. If there's any kind of light around you doing this, then I'd recommend also covering it with a heavy blanket or cloth or something, just in case some light makes its way possibly through the zipper openings and such. The point being is we want to keep any light from entering this at all. I'm doing this outside. I'm doing this after the session of the Orion Nebula that I shot. I'm treating the Dwarf Lab like I would treat a DSLR or a mirrorless camera. When we take these darks, they need to be taken at the same exposure, gain, and temperature. Now, with a cooled astronomy camera, we can control that temperature of the sensor. With a DSLR and the Dwarf II, we can't control the temperature of the sensor. The best that we can do is shoot our darks at the same ambient temperature that our light frames were taken at. So that's why I recommend doing this outside immediately after your imaging session. That way your darks are the best that they can be for you. You're also going to want to shoot a new set of darks after every session, again, so they match your light session as closely as possible. You can try and use them again if the next time you go out, the ambient temperature is the same temperature that it was when you created your darks the last time, but a swing in temperature is going to make a difference in these. So my recommendation, always shoot a new set of darks right after your imaging session. Okay, so now we've got it in the bag. We're going to go back into the app. We'll hit our photo button. Obviously, we don't need to worry about focusing or calibration or anything like that. We're just going to come over into our Astro mode. We'll hit our feature button. We're going to hit the more button, and we'll change the count to 25. Hit confirm. We're going to come over to our settings and make sure our gain is the same gain that we shot at that night. And for me, that is 80. We're going to change our exposure to match what we shot that night, which again was 15. Close our settings and then hit the red button to start the imaging session. So like I said, no focusing, no calibration, no selecting an object. You just simply set your exposure, like you see at top in the green text, to the same exposure and gain that you shot out that night. So it is currently now going to take 25 images for us, and it will not be able to stack them because it's nothing but black. There's no data for it to stack against. So we'll let this finish, and then I'll show you guys how to copy both your light frames and your dark frames off of the Dwarf II into your computer for processing with Siril. Okay, now we need to get the files off the Dwarf unit itself. There's two ways that you can do this. The first way is you can just remove your SD card from the back of the Dwarf. The card comes with an adapter, so if you don't have a memory card reader for the micro SD card, you can use the adapter that came with the card and just insert it in and then put this whole thing into your memory card reader, or if you have a slot in your PC, and read the files that way. The second way, and I'm going to put this card back into the unit, is to use the USB charging port on the bottom of the Dwarf II. And for that, you'll need a USB-C to a USB-A USB cable. Plug it into the bottom of the base, and then the other end plugs into a USB port on your computer. We're going to turn the unit on, open up the app, connect into the Dwarf II, and once you're connected, again, close this main window that comes up so we can get back to the main screen of the app, and tap on your settings button, and then on camera settings, scroll down towards the bottom, and right here where it says MTP mode, you want to turn that on. Then open up File Explorer, and you're going to look for the Dwarf II in your list of devices connected to your PC. And there's our SD card. And this is the same view you'll see whether you're doing it this way with the USB cable, or if you're just inserting the micro SD card into your computer itself. So you're going to want to open up the SD card. And this can get a little confusing if you've used the unit for a while and you've gone and imaged multiple targets and done multiple go-tos. You're going to stay away from anything that says go-to. That's not what we're looking for. You're going to look for a folder that has the word raw in it. There's no indication in the file name of what you have imaged that night. It's one of the many suggestions that I made at Dwarf Lab that it would be nice, instead of this number with the date and it appears to be time in seconds possibly, actually put the name of the object. So in our case, it would be nice to see Dwarf_raw_Orion, and then maybe with the date and time embedded afterwards. It would make it a little bit easier. So right now, just look for your raw folders. You can reference your date modified to help find what you're looking for. But what you can do is come down, like I know this one is my Orion Nebula. So if I open this up, you'll see all the FITS files, and these are your individual images that were taken that night. So I did 15-second exposures. I did 200 of them, so I've got 200 FITS files. That's not what we're looking for to verify. If we scroll down, you'll see a stacked.png. If you open that up, that'll show you the stacked image that the Dwarf II created that night for you as you're watching your phone screen. So just as a check that you have the right directory, open up that image. There's the Orion. That's the stacked image that we took that night. So I know I'm good. So I'm going to take note of the name of that folder. So 5192 is what it ends in. And I'm just going to go back up to the SD card, right click and copy. Now I need to create my working directory for Siril. So you can create this anywhere you want on your hard drive. You can call it whatever you want on your hard drive. It doesn't matter. Mine, I have a folder called Sessions and then one called Dwarf. So in here, I'm going to right click, say new folder, and I'm just going to call that Orion. I'm going to open up the Orion folder. and I'm going to right click and hit the paste button to copy the files from the Dwarf II SD card into this folder. And this can take a couple minutes depending on how many images that you have on that SD card. Okay, the file copy is complete. The first thing we're going to do is rename this directory. So just hit my F2 key and I'm going to call this directory lights. You need to make sure that you do this because Siril's script is going to look for a folder named lights. If you don't name it correctly, the script will fail. Once it's renamed, open it up. Again, there's all of our fits. That's great. We're going to scroll down to the bottom and we have to delete this JSON file and the stack PNG file. Again, if these are left in this directory, the script is going to see them and it'll fail. So select them and delete them. You should only have your fits files. Triple check it when you do this. So we are good. We have our lights folder with nothing but our image files in them. So now we're going to go back over to the Dwarf and we're going to locate those dark files that we took. Again, we need to look for the raw folder. Now, if you don't want, I highly recommend that you take the darks like I was talking about earlier, but if you don't want to and you just want to run through this really quick, you can find the dark folder that the Dwarf created when you ran through the Astro dark procedure, which is right here. It's got the word dark in it. If I was to open this up, you'll see that there are 13 folders in here, each with 15-second exposures. The difference between them are the gain settings. So this one's gain 30, this is gain 70, 110, and so on and so forth. If I wanted to use these, I shot that image of the Orion Nebula that night at gain 80. I would come in here and just copy these 3 files. For what we're doing, 3 dark files are not enough, but this will allow the script to run if you don't want to shoot those dark files. But your results will vary. Best that you do, as I was recommending earlier, and just create a set of your own dark files for this processing procedure. So let's go back up again. We need to find the darks that we took. Again, using the date modified over here, and we're looking for raw folders. The darks that we took were not stacked because there was no data in there, right? We had the lenses flipped down, in the bag. There was no stars or anything for the Dwarf II to use to line and stack up the images. So there is no PNG file here. So these are the 25 dark frames that I took that night. So again, we're going to back up and we're going to copy that folder and we're going to come back over into our working directory that I created a few minutes ago in Orion, where our lights folders are at, and I'm going to paste my darks in there. Similar to what I did before, we're going to rename this folder, except this time we're going to call it darks. Again, it has to be darks or the script is going to fail. Open the folder up, scroll through and make sure you have nothing but .fits files in there. So that means we have to delete this JSON file. Again, verify there's nothing but fits. We'll come back up to Orion. Now our working directory, which is called Orion, contains our dark files and our lights. We're now ready to go and run the script in Siril to start the pre-processing and stacking. Okay, 2 pieces of software we need for this to work. The obvious one is Siril. I'll leave a link in the description to the website. It's a straightforward install, so I'm not going to bore you guys with going through and installing it. Select your operating system, download the file, double click it, follow the prompts, and you'll be all set. The second piece is Starnet, because we're going to be removing the stars from the image before we actually process the image, and then later we'll put the stars back in. This one I'm going to go over a little bit because some people can get hung up on the installation for this. Even though it's quite simple, I just want to go through to make sure we're all clear on it. So starnetastro.com, again, link down below. You want to click on the download link up on the top, and you're going to scroll down closer to the bottom, and you're looking for Command Line Tool version 2. This is the only version of Starnet that will work with Siril. I'm on Windows, so I'm going to click on the link for the Windows. It's just a zip file. Download that, and it's 177 meg download, so it'll take a minute depending on the speed of your internet connection. And we'll come right back as soon as this one's done. Okay, the download's completed, so I'm going over into my downloads directory, and I'm just going to right click on the zip file, select extract all, and then the extract button. Give that a few minutes to finish, and we are left with our Starnet folder. Okay, so now that it's extracted, I'm going to open up the Starnet folder because it's kind of double nested in here. I'm going to right click and say cut, and I'm going to move it over to a different location on my hard drive where I keep all of my Astro tools that I use. So it could be anywhere in your hard drive. The name of the folder doesn't matter. I have a folder called astrophotography right in the root of my C drive. So I'm just going to paste Starnet into that folder. And that keeps it organized with everything else that I have on my machine. So that's it. That's all you need to do to install it. It's not even an installation. Just download it, extract it, move it someplace on your hard drive. Now we want to go over into Siril and let Siril know where Starnet is at so we can use it. With Siril open, we're going to come over to our menu button. We're going to hit Preferences, and we're going to come down to Miscellaneous. And right here where it says must point to a valid Starnet executable, we're going to click on the button and we're going to browse over, in my case, to my astrophotography folder, my Starnet folder. We're going to select the executable for Starnet. So starnet++.exe. Hit apply. And that's it, you're done. Siril now can use Starnet to remove and put back the stars in your images. Okay, one more step, then we can start processing your images. We need to download an additional script that's available from Siril's website. We'll do that by, again, within Siril, we're gonna come back up into our menu, and we're gonna click on Get Scripts. It's going to take you to the documentation webpage, and right here underneath Getting More Scripts is the web address to go and get those additional scripts, including the one that we're looking for today. So we're going to click on that link. It'll bring you over to the repository. We want to click on the pre-processing folder, and the script that we're looking for in our instance is OSC pre-processing without flat. So just click on OSC pre-processing without flat. Come over to the little download button here on the top right. When it prompts you where to save them, this is something else just like we did with Starnet. I like to keep separate in my astrophotography folder, so that's where I'm going to put this one. So I'm going to come to my C drive, astrophotography, and within there I have a folder called Siril Scripts. I have a folder that I created called Siril, and I'm going to save that script right in that folder. Close the browser because we're done with that. So this is completely optional, but if this is your first time using Siril and you're looking at using it for your Dwarf processing, this might be something you want to do just to make it easier for yourself. So let's go over to my astrophotography folder, my Siril scripts in Siril. This is the script that we just downloaded. This is the name that you're going to see up in the scripts menu once we get it loaded within the program. That may not make sense to a lot of you. So what you can do is just rename it, and whatever you rename it to is what you're going to see in your scripts menu. So we'll go ahead and do that, and we'll just call it Dwarf Processing. Now what we need to do is tell Siril where this new script is at. So it's easy enough. Just come up top here so you get your path to the folder where you save the script. Right click and say copy. And then again, back over in Siril, we're going to go up to our menu. We're going to hit Preferences, Scripts, and create a new line, and then right click and paste. So now we just pasted our new path to that script that we just downloaded, so Siril knows where to look for it. Hit your refresh button right below, and then click Apply. Now if we come up to our Scripts menu just to verify, we see we have a script called Dwarf Processing. With all that in place, we are finally ready to start processing our data. All right, so before we get started with the processing, just a little bit of a recap. If you remember in the beginning of the video, we set our working directory. Mine was under Sessions, Dwarf, Orion, and this is where we copied our darks and our lights. We need to tell Siril where this working directory is. So over in Siril, your little blue home button, that's how you set your working directory. Click on that. I'm browsing over to Dwarf, double clicking on Orion, and then just clicking Open. Top center of the screen, you want to make sure that it's pointing right to your working directory. Not to your lights directory, not to your darks directory, to the directory that contains the lights and darks. So in my case, again, Orion. Once that's set, we're ready to run the script. I'm going to start the script and I'm going to immediately stop it because I'm going to show you some warnings that you're going to see fly by the screen and just explain what they are. So we'll come up to Scripts. We're going to click on our Dwarf Processing. This is again the script that we downloaded from Siril. We're going to click on it and you'll immediately see in the console that it's going to start running. Like I said, I'm going to click stop here so I can scroll up and show you guys what some of these warnings mean. The first one is right here where it says you should enable the developer mode in order to create symbolic links instead of simply copying files. On Windows, this is a good thing to enable. It will allow it to create shortcuts. That's what symbolic links are, versus making a copy of the file, therefore taking additional hard drive space. So, if you have a ton of hard drive space and you're not worried about it, then that's fine. This is not a requirement, it's just a recommendation. But if you do want to enable developer mode, just hit your start menu and just start typing developer. When you see the developer features come up, click on that, and right up here in developer mode, Flip it to on. It'll give you a warning about it's protecting you from apps outside the store. That's fine. Just click yes. And now subsequent runs of any of the scripts within Siril, this warning will go away. I like to turn it on. Like I said, it saves a little bit of hard drive space for you. The second warning that you're going to see with the Dwarf is this one right here, and you'll see it multiple times. Talking about the Bayer pattern found in the header of the light images is GBRG. Default serial settings, that Bayer pattern is set to RGGB. All this message is telling you is, hey, I was expecting RGGB. The one that I found in the images that you took with the Dwarf are set as GBRG, and that's fine. And these letters, GBRG is green, blue, red, green. RGGB is red, green, green, blue. It's just a different way, different sensors put together a color image, let's say. Again, this is a warning. There's nothing you need to do about it. So this is fine. I'm just going to clear this screen by typing clear at the command line and go back up to my scripts now and just click on the Dwarf processing script that we downloaded, and we'll let it complete this time. Doesn't take very long. The more exposures you have, the more time it'll take, but it's generally only a few minutes. Depends on your processor, the amount of resources you have on your computer, and again, like I said, how many files that you have. Okay, once you see a total execution timeline, mine it took 41 seconds. Also down on the bottom it says rejection stacking is complete. That's your indication that the script has completed processing and stacking your data. So now we're going to come over to the open button, and in our working directory we'll see a result.fit file, which is our stacked image, and you also see a process folder. This is all everything the script did to register and align all these images together. What we're interested in is result.fit. So just double click that and our image will open up in what's called linear, which is generally pretty dark. It's normal. The Orion Nebula is a pretty bright target, so don't expect to always see the image when you first open it up. If you're shooting something that's dimmer, most of the time this image will look almost completely black, if not completely black. But to get a better representation of the data that's in here, if we come down to where we see linear, and that's the state we're viewing it in right now, click on that and change it to auto stretch. Don't let the green freak you out. Come down here, the little chain button next to the auto stretch. If you click on that, it'll unlink the stretch, and that gives us a better version of what we're expecting to see. The first thing you probably notice, you're not seeing the stacking artifacts from the rotation. We actually are, but they're just represented differently because of the way that Siril registers and stacks the image. But regardless, we still want to get rid of all these little dots and everything that we're seeing down the bottom. This is from the stacking process and how the images were slowly rotating as we were taking them that night. So the first thing we need to do is crop the image. What I like to do to make sure that I can see all these artifacts on the side easier is come down and take myself out of auto stretch and go into histogram. Now this really blows out the image, but it also pronounces the artifacts that we're looking for. If you look along the bottom here and on the right hand side, literally all the way around. So looking at where those artifacts are at, I'm just going to use my left mouse button. I'm going to hold it down and I'm going to draw a selection around the Orion Nebula that does not include any of those artifacts in there. Once I have that position the way that I want, and once you have the box drawn, you can also make adjustments to it, right? I can hover my mouse over any of these sides and go up and down, left and right. You can also click anywhere within that selection and move that selection box around. So get it positioned where you like, where there's no artifacts. Then we're going to right click and we're going to hit crop. We're going to come back and we're going to change from histogram and go back into auto stretch, so it's easier on our eyes. And the next step is we're going to do what's called a background extraction. The background extraction is going to even out this gradient that we have from light pollution in the sky. Whether you're just in an area where there's a lot of light pollution, or maybe your neighbor's light or a street light or the moon, anything that can cause kind of stray light to get into the image, the background extraction will help smooth this background out. So we're going to come up to image processing and background extraction. I'm not going to go too deep into this. I have another beginner's tutorial that I put out a few months ago intended for people who are using traditional scopes and mounts and everything. And I go a little bit deeper into all these settings in that video. So I'll leave a link up in the corner here for that if you guys want a little bit more in depth on it. So for now, we're just going to do this quick and simple. Make sure your interpolation mode is set to RBF, which it is by default. Smoothing, samples per line, grid tolerance. Real quick, I'll touch on this. If I hit my generate button, it places all these samples for me automatically. You don't need this many when you're using RBF, and this actually causes you more work because we don't want samples like this that are sitting on top of stars. We don't want samples like this that are sitting on top of our nebula that we're trying, because we're working on the background, not the nebula. We don't want it to identify the stars and nebula as part of the background. I'm going to hit my clear button. Again, as long as you're in RBF, you can do this manually, and it's a lot easier than chasing the samples around that are generated automatically. Just find empty areas of the sky in your image, place a sample there, and just go around and do that in a few spots. You don't need to go crazy. This particular interpolation method does not require a lot of samples to do a good job. Just, whatever you feel works, and you can always go back and add more. So I'm just going to come around. I usually always try to catch the corners, at least, get a sample in the corner. Like I said, don't put them on bright stars. If you accidentally click on a star, just right click on it. It'll take that sample away for you. But there's no method to this. I'm just putting it where I think they would work, staying off the stars. And we'll put one down here. So I think that'll be good. Once I'm happy, I'm going to come over and hit compute background, and you can see it smoothed out our background. Once you're happy, hit the apply button. Now we want to correct the color of this image. And we do that by coming up to image processing, color calibration, and photometric color calibration. What this tool is going to do is it's going to actually look up the Orion Nebula against a catalog and color correct the image as a whole based on what it knows about the Orion Nebula. So what you do is you come up under image parameters, and you have to type the catalog number of the object that you image that you want to color calibrate. If you don't know the catalog number, Google's your friend, right? So if I come over to Google and I typed in the Orion Nebula, hit Wikipedia or any other site that comes up, somewhere in here, it'll tell you your catalog number. M42 is all we need. Sometimes you'll see an NGC number as well. That'll work as well, but we'll use M42 for this example. So back into photometric color calibration, I'm going to type M42. And then I'm going to click find. It comes up. Sometimes there may be 2 or 3 results. It doesn't matter which one you pick. It just means it found them in multiple catalogs. We're going to select that. That automatically sets our rate ascension and declination, which is just the coordinates. Think of latitude and longitude on Earth. Rate ascension and declination is a similar thing, but up in space. That's how we know where all these objects are at. Focal length, we're going to set that to 100 because that is the focal length of the dwarf. Make sure your pixel size is set to 1.45 because that is the pixel size of the sensor within the dwarf. And then click OK. And if you watch the image as I click OK, you should notice a change. Not only did it balance the colors slightly for us, it also flipped it. And that's because option right here, flip image if needed. So it determined that the correct view for this needed to be flipped over, so it flipped it for us. So we are color corrected now. The next thing you probably can see, hopefully, maybe not on the YouTube video, but there is a slight green tint now, and that's common with shooting with any kind of a color camera. So we're going to take care of that by coming up to image processing and then going into remove green noise. All you need to do is click apply, and it'll knock down that green noise for you, and then hit close. Now, what I like to do, and it's the reason why I had you guys install Starnet in the beginning of the video, is I like to remove all of the stars from the image and then just work on the nebula itself. And then once I'm done, I can put the stars back into place. I think it's a really good technique. You don't have to do it. You can skip this step if you want and follow through with the remaining steps, and then skip the step about putting the stars back in, obviously, if that's what you want to do. But I recommend, at least trying it this way and see if it works for you. So to remove the stars, we're going to come up and we're going to go into image processing, star processing, and Starnet star removal. Generate star mask should be ticked by default. If it's not, make sure it's enabled. That's going to be where our stars are going to be stored for us as a separate image. And then you also want to select pre-stretch linear image up at the top, and then just hit execute. This can take a couple minutes, so be patient. You can watch it down on the console here. It says that it's running Starnet, and once it's done, you will see a starless image appear on your screen as it just did now. So that was pretty quick. For this image, that was 10 seconds. We're still in a linear mode, right? So if I come back out of auto stretch and into linear, this is actually what our image looks like. If you were to try to save this out of Siril right now as a JPEG to share on Facebook, and you were sitting, and this has happened to people, this is why I'm bringing this up, but if you were to save this as a JPEG, as soon as you open it up, it would actually look like this because it is still in its linear state. The data has not been stretched yet. Some of it can be seen because the Orion Nebula is so bright in the trapezium area, but that's all you're going to get. So we need to stretch it. So we're going to stay in our linear state. We're going to come up to image processing, and we're going to start stretching. There's actually 3 different tools you can use for stretching. Generalized hyperbolic stretch is probably the best way to do it, but it's more of an intermediate to expert type of stretching. So I'm not going to cover it in this video because I want to keep this easy and simple for beginners to Siril. But again, I do have a video on that, so I'll leave a link up in the corner if you guys are interested in it. So we are going to start with the assigned transformation. So clicking that, we're simply going to take our stretch factor, We're going to watch our image, and you can see as I move it over, it's pulling the data forward. It's stretching the data, right? All the way to the left, we're completely linear. As I start moving it, it starts pulling that data forward. So what I like to do, you don't want to do all your stretch in one fell swoop. So just stretch it a little bit till you start seeing it. It's kind of hard again because the core of the Orion Nebula is really super bright, but generally you just want to bump it up until you start seeing your object that you've shot. Once you're happy with that, hit apply. Then we're going to come back up into image processing, and this time we're going to run the histogram transformation. This one will allow us to tweak things a little bit more. So just to give you a quick explanation, you can see this peak shooting up on the left-hand side. This is actually our data that we're seeing in the image right now. We have 3 triangles. The one on the left represents your shadows, so your dark areas of the image. The one in the middle represents the midtones, and the one on the right are your lights, your whites, the brightest parts of the image. The whites we're going to leave alone. That'll always sit over on the right, but we're going to start by grabbing our midtones, and we're going to drag it over towards our data. And when you release it, you can see what it's doing over here. So if I go back the other way, it's a little bit darker. I come closer, I'm making it brighter. You don't want to go too bright with it. And it's a preference thing, right? There's no right or wrong way of doing this. Just play around with these until you get a feel for what they're doing. Get the image to where you think it looks good to you, then you'll be fine. Where it says 1 up here, this is actually a zoom level for our histogram. So I'm going to hit my plus button to zoom up on this a little bit. And I can see I've got some space between where the data starts and the left side of the image. So there's no data there. So I can actually grab my darks and just drag it over a little bit to where the data starts. You don't want to go too far because you start losing it. You want to watch your clip percentages over here. If you start seeing those numbers go up, then you're clipping data, which means you're losing data, which is not what you want to do. So as you're moving this over specifically towards the histogram, your darks over towards the histogram, make sure you're not clipping any data. Okay, so I'm going to say that looks good for me now. I'm going to hit apply and then close. And now, because again, down the bottom, we're still in the linear state, but we stretched. If you were to save this out as a JPEG, this is what you would see. And you're ready to start doing a little bit more work on it. So the next thing that you can do to try to bring these colors up just a little bit more is come up into image processing and color saturation. And there's a few different ways that you can use this. Global is just that. It'll cover everything in the image. So if I start to grab my amount slider and move it towards the right, you can see the colors start coming in pretty vividly. The background factor, and I don't think we're going to have an issue with this, but as you're increasing your saturation, if you notice your background is starting to take on some of those colors, you can slide this one way or another to kind of protect the background from that color saturation. So let's go to reset. The other settings up in the hue are specific to other colors. So if I just wanted to pull in some of the reds, pinks and reds, and then move the slider, I'm just saturating the reds and the pinks that are within the image. Same thing, I'll have to reset again here. Any of the colors that you have in there, orange and brown, if you see any orange and browns, you want to bring that up, you can bring that up like that. I think you get the idea, the cyan blue. So it's just a way to individually increase the saturation on specific colors. Once you make an adjustment, hit apply, the box closes. If you want to do more work on it, just open up color saturation again. You can go back and do more work on it. So I'm going to try and do a little bit around these reds. And you probably noticed as I was showing you, if you go too far, sometimes the colors will start getting blotchy. So you got to watch, even though it may look good in one area, the other areas they start looking like somebody hit them with a crayon sometimes. So, but again, it's all preference. So just play with them. We'll hit apply. I'm going to go back into it one more time and maybe hit it with some global just to get everything across the board. And yep, I think that looks good. All right, so very important. Once you're done doing everything you're doing, make sure you come over here and hit your save button. Now, another optional step, and I'm going to walk you through it, but I like to take it into Photoshop next and use a couple tools within Photoshop to try to make things pop a little bit more. You don't have to. If you don't have Photoshop, you can use GIMP, or if you just want to be done, you're like, hey, this looks great now, then you can skip this next part and go right into the star recomposition where I add the stars back in. But I'm going to take it into Photoshop. We're going to come over to this little arrow button here, and this allows me to save it as a different format. So under supported image files, I'm going to save it as a TIFF. I'm just going to leave the name starless_result. That works for me. Click save. I'm going to be using Camera Raw in Photoshop, which requires it to be a 16-bit TIFF. So I'm going to make sure that's selected and then hit save. Now I'm going to come back into my working directory. And while we're here, here's the star list, the one that we were just working on. Here's the star mask. That's all of our stars that we'll be adding in later. And then that's our original file that we opened up initially after the stacking was complete. But here's my TIFF. So I'm just going to double click that to open it up into Photoshop. And really just some minor tweaking. So under filter, camera raw filter, there's a lot of cool tools in here that just allows you to do some minor tweaking. When I say minor, I mean take it easy. It doesn't control it for you. We can start up in the light folder here. Again, just play with the sliders. I usually start with some contrast, just a little bit. You don't want to go too much, right? You see what happens when you start going crazy with the stuff. And it's easy to do as you're sitting here and you're going a little bit at a time and you're like, that looks good. And then you a little bit more and you're like, that looks good. And then next thing you know, you're so deep into it, you didn't realize that you really overdid the image. So a little bit at a time. So like I said, a little bit of contrast. The highlights, I'm actually going to try and go down the opposite way just because that core is so bright. But there's really not too much we can do with the data that we've got. Again, and then shadows kind of help around the faint areas. So if you watch that as I move this back and forth, you can see how it's kind of feathering out the gases around the outer edge of the nebula. Whites, same thing. I'm going to bump that up a little bit just so that core doesn't look like a big blotch as much. Again, it's all preference. And then you got blacks you could play with. That kind of helps with the edges too. Try and look at the image as a whole as you're making these adjustments. If you start focusing on one area and making adjustments and you're not paying attention to everything around it, that's where you can get into trouble sometimes and have to start all over. So I'm going to call that good for the light section. We also have a color panel here. Usually I just bump up the vibrance just slightly. Again, not too much. Effects, again, you can play with them. What I found is the clarity slider just a little bit. It almost like it sharpens it, but it'll give you a little bit more detail around the edges in between the different types of gases that are in the image. You can go into color mixer as well, and you can adjust. You can play with your hue, your saturation, and your luminance. Generally, I stay away from the saturation since I already did that in Siril, but there's nothing wrong with trying it out if you want to. You can adjust the luminance of the different colors here. So if I grab like my oranges, try to work on that center a little bit. Actually, I think the oranges, I like the orange where it's at. I'm not going to mess with that, but this is what I'm talking about. Just play with the sliders. See what you come up with. See what you like. See if we can't get a little bit maybe of the blue to come up. Same thing with the aquas. I think the colors look pretty good for the data that we have. I'm not going to play with them too more. If we come into detail, you can do some sharpening and noise reduction right here within Photoshop. Again, you got to be careful, right? Especially with the sharpening. It'll really start making it look crazy. So just a little bit, if you come over too far, you're sharpening the noise as well as the data that's in the image, as well as the nebula. So be careful when you use it, a little bit at a time. If you see any noise in your image, you can bump your noise reduction up a little bit. If you go too much with the noise reduction, it blurs it, right? So that's effectively all the noise reduction function is doing. So just bump it over a little bit. When you're happy with it, hit OK. There's our final result. Just come over and say File and Save. Then you can close Photoshop. Back over into Siril, the last step that we have to do is to add the stars back in. So this is our .fit file, as you can see up here, that we worked in initially. We need to open up our TIFF image that we just modified in Photoshop. So open, and then the starless result .tiff, and then we need to save this back as a 32-bit fit for the star recomposition. So again, we're going to hit our down arrow. We're going to make sure that we have fit selected, and then this time I am going to give it a name so I know what I'm looking at, and I'll just call it M42, which is our catalog number for the Orion Nebula. Click Save. Make sure we set 32-bit floating point, and then save. Time to put the stars back in. So image processing, star processing, star recomposition. All right, so we have two panels in this. Background stretch parameters, star stretch parameters. You can see both say none right now. The idea is we're going to load this image into this panel, and then we're going to grab our star mask, which is our stars, and load it in over here, and then combine the two. So we're going to click here under background stretch parameters, and we're going to open up the M42.fit, and then over on the star stretch parameters, we're going to click on that, and we're going to open up our star mask. And you can see it's already bringing it back because, again, they were pretty bright in this image. Sometimes you won't see them at all. Sometimes you'll just see them slightly. But what's really nice about this is using our stretch factor under the star stretch, I can bring these in as much as I want just by increasing my stretch factor. If I go all the way over here, then that's just crazy. That's way over the top, right? But just to show you how powerful the tool is. And then you also have your symmetry point, right? So usually, and it seems better with the dwarf data anyways, I just manually slide this over. And I'm watching the stars just to kind of tame them down a little bit as I'm bringing them back in at the same time. I don't like the stars to steal the show usually. So once you're happy and you got the stars stretched in the way that you like them, just hit the apply button, then close. And that's our reassembled image. And if you notice up here, it says unsaved star recomposition results. So again, if you were to close Siril right now, everything goes away. You just lost all your work. So save button's not active because there is no file for this yet. So we're going to hit the save file button again. I like to save it as a fit first, just to have it to go back to as the original image. So I'll just call this one M42 final, 32-bit. And then we can come back and save it as a JPEG or a PNG, whichever you prefer. So we'll leave it M42 final.jpg, save it. Quality 100%, of course. Now there's our final image that we could post up on social media. So let's compare our processing compared to what we got out of the Dwarf. So we'll open this up and I'll just use photos, and then we'll open up the one that we got out of the Dwarf and kind of do a side by side here. So left hand side is all the processing we did in Siril, and right hand side is what came straight out of the Dwarf II. I think the differences are pretty obvious, and you know, everything that I just went through today on this tutorial, again, I can't stress enough, it's all about preference. Don't let anybody tell you that you oversaturated it, or you didn't stretch it enough, or you stretched it too much. There's a point in time when you're doing this post-processing that it becomes artistic. So it's what you like. So like I said, as requested, I hope a lot of you find that helpful and you're able to learn how to pull more data out of your images and get a better end result. Good luck to everybody on both giveaways now. Thank you to all my channel members, both here on YouTube and on buymeacoffee.com. Appreciate everybody's time watching the videos, liking, sharing, commenting. It's a lot of fun interacting with you guys. I think we got a nice little community that we're starting to build here on the channel. Appreciate each and every one of you. See you on the next video, and clear skies.